This is section 1.6, which is Graphical Transformations. It is also connected to the AP standard 1.12, which is transformations of functions as well. Okay, so this is kind of a overview of everything from Algebra 2, but this is just talking about the different transformations we can have for any function. So starting with translations, if we have a value inside the parentheses with the x, or inside the absolute value, or inside the square root, that is going to shift it to the left or right. And what we need to remember is that it's actually opposite of what we would think. So if it's minus c, that's going to move it to the right. And if it's plus c, that's going to move it to the left. Now, if the value, the constant, is outside the parentheses, or the absolute value, or the square root, or whatever function we're looking at, then that's going to shift it vertically up or down. Plus c would shift it up, and minus c would shift it down. So if we look at our two examples down here, assuming our parent function is the absolute value function, so y equals absolute value of x, this equation right here would be a shift down 4, and this would be a shift to the left 2. Okay, next is talking about reflections. So the placement of the negative in the equation tells us how the graph is reflected. So if the negative is outside, that is going to be across the x-axis. If it is inside, that's across the y-axis. And both negatives is both across the x and the y, which we call through the origin. Okay, so our example down here, we're going to look at x-axis symmetry and y-axis symmetry. So if we're starting with this function, and we had x-axis symmetry, or x-axis reflection, that would mean that we're going to do y equals negative x cubed minus 2. So that negative would end up distributing, so we'd have negative x cubed plus 2. So this would be across the x-axis. So this would be an x-axis reflection. Now, if we had across the y-axis, how that would look would be y equals negative x cubed minus 2. And how that's going to change is we think, okay, if we have a negative value cubed, it stays negative. So that would be negative x cubed minus 2. So that would be y-axis reflection. And if we look at both of those equations, we can see these are not the same. So we know that the placement of the negative is going to give us two different results. Okay, the next part is stretches and shrinks. And this is probably, of the transformations, the most confusing one to remember, because the placement of the number makes a difference, and also whether or not it's a stretch or a shrink. So we're talking about horizontal and vertical stretches and shrinks. So starting out with the c inside the parentheses, that means that it's going to be horizontal. It could be a horizontal shrink, could be a horizontal stretch. So if our c value is less than 1, it is going to be a horizontal stretch. Okay, and I'm going to put in parentheses here, that's going to make it look wider. Okay, so then if c is greater than 1, that's going to be a horizontal shrink. So if you're thinking of moving your hands, like stretching something to the left and the right, it's going to stretch it out and make it look wider. If you're compressing something from the left and right, it's going to make it look narrower. Okay, So now if we go over to the other one, if the C is on the outside, it's going to be a vertical stretch or shrink. Let's write that a little bit better. So we're still thinking stretch and shrink, but now we're talking about vertically. So you can imagine either stretching something out up and down or compressing it from the top and bottom. So in this case, if we have C is greater than 1, it's going to be a vertical stretch. And if C is less than 1, it's going to be a vertical shrink. But I also want to put in here a vertical stretch is going to make things look narrow, and a vertical shrink is going to make them look wider. So what I want you to pay attention to is that C is less than 1 and C is less than 1. In both of those cases, it's going to make your graph look wider. If C is bigger than 1, C is bigger than 1, in both cases, it's going to make your graph look narrower. Not by the same factor. And that's what we're going to look at in this example. But if you see a number that's like 1/2, you know your graph is going to look wider. It could be either a horizontal stretch or a vertical shrink, but it just depends on the placement of the constant. So if we look at y equals x cubed minus 16x, we're going to start with a horizontal shrink. So we're going to do 2x cubed minus 16 times 2x. So that would be what it looks like if we're putting the number in with the x. The opposite, so a vertical would be the 2 on the outside, x cubed minus 16x. So both we're inputting a 2. One, we're inputting the 2 inside the parentheses with the x. One, we're just multiplying the whole equation by 2. So in this one, we're going to get 8x cubed minus 32x if we simplify. And over here, we're going to get 2x cubed minus 32x. So in both of these cases, they're going to look narrower. But this is a horizontal shrink, and this is a vertical stretch. Oops. Okay, so again, the purpose of showing you this is that you can see we have 2 different equations here. So just plugging a 2 in isn't going to give us the same graph. It depends on if it's a horizontal shrink or a vertical stretch, and it changes our graph. But both graphs, if we were to graph them on our calculator or on Desmos, both graphs are going to look narrower than the original. Oops. Okay, our final example is how do we put all these together now? So if we have f of x equals x squared, our first one, we're talking about all the different things that are happening. So I have the 3, I have the minus 2, and I have the plus 5. So we have 3 different transformations happening. So this would be a vertical stretch. And I know it's vertical because the number's outside. It's not inside with the x. And the number is bigger than 1, so that makes it's going to look narrower. So it's a vertical stretch. I know that we're moving to the right 2 and up 5. So all of those tell me what would happen to my parent function f of x equals x squared. Okay, the next one I have 1, 2, 3 different transformations. So the negative out front is going to be a reflection. And because it's outside of the parentheses, it's going to be a reflection over the x-axis. Okay, the 4 with the x, that is going to be, so it's a number bigger than 1, so it's going to make it look narrower, but it's horizontal because it's inside with the x, so it's going to be a horizontal, and it will be a horizontal shrink because it's going to make it look narrower. Okay, and last, the -7 means we're going to go down 7. Okay, so that is kind of a quick review of transformations.